Okay, so this is basics of derivatives. So what a derivative is, the slope. Uh, um, so let's say you have a line, you're graphing something like y equals 2x. So let's just graph this function. Let's see, when x is 1, y is 2, when x is 0, y is 0, when x is 2, y is 4, when x is 3, y is 6. So you see how it just goes up like this in a linear straight line. And then, so what a derivative does, if you take the derivative of this function, so that's what you do when you go like this. You're figuring out what the slope is at any given point. So yeah, the slope of this line is 2 because at any point, at any point the change in y over the change in x is going to be 2. 0, 0, and then there's this point 2, 4. And then since the slope is 2, you can go up 1, up 2, 1, 2, change in y is 2. And then, and that's, the definition of slope. And so, since it's a line, the slope is going to be the same everywhere. And what somebody figured out was that for one of these simple kind of functions, you can it's called the power rule for derivatives, and you can figure out the derivative of x at any point x along this, any of these points. You can figure out the slope of the line at any point by taking the derivative. And the way you do that is you multiply the coefficient times the exponent, and then you subtract the exponent by 1. So for the derivative of this y equals 2x, you're going to get 2 times 1, which is just 2, and then x to the 0. And so x is 0, it just equals 1. So the derivative of y equals 2x is just 2. And that works because anywhere along this line, the slope is going to be 2. Let's see. So let's do the slope of another parabola. Now we're going to graph y equals x squared. So we're going to graph it as we go along x. When x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. When x is 4, y is, up here. So you get is this curve that's like this. And now, so what happens is the slope of the line gets bigger and bigger as x gets bigger and bigger. So now we're going to use the power rule again to get the slope. So the way we do that is just multiply this 2 times the coefficient, which is 1, so that's just 2. And then we subtract 1 from the exponent, so it's 2x to the 1, or just 2x. So what that means is that at this point 1, the slope is going to be and at the point 2, if x is 2, the slope is going to be 2 times 2, 4. And at this point, when x is 3, the slope is going to be 6. And so that's what it is. So yeah, that's the basics of derivatives. It's the slope of the line. And so, okay, something like this. And so what was happening in these problems, what you do is you want to figure out where the derivative equals 0, and that's going to be where this happens, where the extrema happens, where it goes from positive to negative. It's going to go through 0. So let's take the derivative of this one. Negative 2 times 2 is negative 4x, and then this goes down to 1, and then this x, 1x times 1, so that's just 1. So this curve, the slope at any given point is negative 4x plus 1. And so in these problems that you have, what you do is you try to find this, because that's where your cost minimization or maximization is, depending on if it's an upward or downward parabola. So that's the big step in the problems that we're doing is you just set it to 0 and solve for x. And then when you get, so for this one, maybe this is the cost equation where, it's x equals negative 2x squared plus x. And you're trying to figure out how to maximize x. And then you just solve for x. And let's see, negative 1, negative 4x. And then let's see, x just ends up being 1 over 4. And then you just, what you do is you plug it back in, that's probably going to be a y. And then figure out the y component and then solve for the cost. So that's the basic way of doing those problems where you need to do a derivative. So what's going on there is if you take the derivative, you can figure out where the slope is 0, and where the slope is 0 is where these change, where this point is in the graph, where it changes from like positive slope to negative slope, and vice versa. And this is the key to finding the cost minimization or the cost maximization, the answer.